Hi, welcome to my talk, Building Custom C++ Tools in the Web. I am Stefan Dirix. I'm a software architect at Eclipse. We are a company providing services for building tools and IDEs for our customers, and currently we experience a huge shift to web-based development, which is one of the main motivations of this talk. Web-based development, what do we mean by that? So let's look at the typical architecture of a web-based or cloud-based tool. So when people say, okay, it's a web-based tool, they typically mean the front end. So the front end, the UI, the user is interacting with is rendered within a browser. While the back end, this could be anything. Could be a Node.js, could be Java, could be C, whatever you like. So this is a classical split. So you have the client, you have the server, and all of this is running in the cloud. However, when you're doing a web-based tool, you don't have to be in the cloud. You could also package everything up. One popular framework for this is Electron, and deliver this still as a desktop application. So for example, Spotify or Slack are typical examples for this. Yeah, okay. So you have maybe you already have existing C++ tooling. Maybe you want to build new ones, and you're only familiar with the desktop-based frameworks. So for example, Eclipse CDT is a very popular choice for that. And now you see, oh, there's so many web stuff. Where do I even start? And yeah, many people have the problem. And this question was, for example, one of the motivations to bring CDT.cloud into life. So CDT.cloud is a very new project hosted at the Eclipse Foundation. And it's intended for hosting components and best practices for building customized C++ tools. And there are already many companies involved, for example, Ericsson or SD Microelectronics, or Renesas, for example, and of course, Eclipse. Components which are there, for example, Trace Compass Cloud, there's Klangly Context, there's CDT, GDB, debug adapter, and the CDT amalgamator. But what we will focus on today is the CDT.cloud Blueprint. Yeah, what's that? The CDT.cloud Blueprint is a template for building web-based C++ IDEs based on Theia. And the idea is, okay, we want to showcase all the CDT.cloud projects, but also integrate other great OS projects if they are a good fit. And in the end, this is basically a selection of Theia and VS Code extensions. One warning, CDT.cloud Blueprint is still in an alpha state, so not everything is 100% ready. You can see cdt-cloud.io for more information, or visit our GitHub project overview page. Okay, yeah, CDT Cloud Blueprint. I already told you it's based on Theia. But Theia, isn't there something else? Yeah, there's also VS Code. And this is a topic. There could be probably 5 talks in a row about the differences and what to do what. However, what's important for us is, what you should keep in mind, is that VS Code is an extensible text editor, while Theia is a framework for building editors. And actually, you don't even have to be an editor. It could also be very customized tools which don't look like normal VS Code or Theia at all. And most interesting part is that VS Code extensions can be used in both. So you can use them in Theia and in VS Code. And therefore, you can, if you want to, run a dual strategy. If you say, okay, maybe I still want to run in VS Code, at least some of my functionality, then you can do whatever is possible, because it's only limited functionality which is available in VS Code, and then do your fully integrated, fully fledged tool then based on Eclipse Theia, for example. Yeah. What we will look now is CDT.cloud Blueprint, as mentioned, and basically what you will see is all the information which was extracted from the various working groups we are active in, and of course of all our customers which are going into web-based tooling. So the first thing you have to think about is language support. So today, this is usually used, done via the language server protocol. So you have an editor, it speaks this protocol, and you can bind arbitrary language servers to it. And yeah, this is really a great concept because you can interchange editors and language servers as you see fit. And yeah, not everything needs to be known beforehand. Yeah. What does this mean for C, C++? When you're looking at the VS Code marketplace, there is CPP Tools. It's from Microsoft. It's very popular and mature, and not only has a C, C++ language server, but it also provides debug support. However, and this is now very important, is it has a restrictive license. It can't be used outside of VS Code. And this is something which is easily overlooked because, yeah, Microsoft has now a good standing. It's open source, and VS Code is open source a lot, and so on. However, there are many parts which are restricted and can't be used outside VS Code. So, for example, if you look at the marketplace, where we have this alternative hosted at the Eclipse Foundation, or you look at other language servers, it's not that uncommon to find this license there. What does this mean for us? So for the CDT.cloud Blueprint, and for you, if you want to use Theia or something else, you need an alternative. You need another language server. And yeah, very popular is ClangD, which is part of the LLVM project, which also provides the Clang compiler. Yeah, it's a fully fledged alternative, and it can be used in Theia and other tools. What does this mean? Basically, ClangD is the choice for all IDE vendors. And yeah, let's just look at this in practice. So I will switch over to my blueprint. You can see it here. Let me make this a little bit larger. So this is CDT.cloud Blueprint, as you would encounter it when you first started. And let's just look at an example file. For example, here we have some main file with a little bit of code. And when I, for example, hover over a rectangle, I can see the documentation to that. I can do source lookup. I can invoke autocomplete if I want to. So everything which you would expect from a modern IDE, and all of this is coming through the language server. Okay, going back to my slide, how does this work? So ClangD works with a compile commands JSON file, which is basically a file which instructs or contains all the information on how the compiler is instructed regarding your source files. And this means, okay, you have to somehow generate this file all the time. So keep this in mind, because this could have consequences on your build integration. For example, you might want to choose CMake because it can generate these files out of the box. Because ClangD is the de facto choice, it's also a focus in the embedded special interest group of the Eclipse Cloud Dev Tools working group. And yeah, this already had some fruits. So, for example, contributed to CDT.cloud by ST Microelectronics is the ClangD context tool. And the idea is, okay, ClangD is the tool of choice. How can we make it work the best in our use cases? And yeah, I wanted to showcase this. So for this, we will look at this workspace. And this has a little bit more complicated setup. So we have an application project, we have a library project. This library project has here some function which is exported, which uses some magic value. And this comes in via some pre-processing. And for example, these values are then coming in via the compiler instructions. Then we have a main file where we then use this sum function. Yeah, and what's great now about this, with this new tooling, is I can just switch between different configurations I have. So in our case, we have a debug configuration and a release configuration built for different architectures. So all of this is just a playground, but yeah, this simulates an Atom and x86 architecture. And here with this example UI, I can now switch between them. So for example, let's switch from release to debug. And we can see this warning here disappears. While when I go back to debug, to release, I can see it come up again. This warning is that there's implicit conversion going on from float to int, which comes in because with this architecture, this type is an int, while with the other architecture, it's a float. So it's pretty interesting. Yeah, it's pretty cool stuff. I can definitely recommend to check this out. Yeah. Another aspect of the tooling is, for example, that many embedded tool chains are not based on Clang, but still will use ClangD. So for example, here, this example is also made with GCC. And when I switch again back to debug, you can see, oh, here's an error coming up. There's some unknown argument. This comes because the compile commands JSON file contains this fstack usage parameter, which ClangD doesn't know what to do with that because ClangD doesn't know what to do with that because Clang doesn't support it. So we added an additional command. And this is here called suppress unsupported GCC flags. And now it's gone. So yeah, this is one of the many ways this tooling can support you. Yeah. Before going over to compilation, let me just shout out something. In the last TheiaCon in 2021, there was a very nice talk, code intelligence in large C++ repositories. So if you're interested in maybe a different approach or other approaches to combat shortcomings of ClangD, I can definitely recommend the talk. Okay, about compilation. So compilation is traditionally very project-specific in C, C++. So you can use a terminal, you can use scripts or tasks, or build your own UI. So it's hard to recommend something useful for everyone here. If you're using CMake, we can recommend the CMake tools. So they definitely make sense. Then we come to debugging. Similar to the language server protocol, this is accomplished via the debug adapter protocol. So you're contributing your debug adapter, and this talks via the protocol with the editor, but then also talks to an existing debugger, for example, some GDB server, including the GDB protocol and, for example, custom extensions, which you are providing. There are many, many debug adapters to choose from. Obviously, there are, which I already mentioned, there are the CPP tools by Microsoft. However, because of the license, we can't use them. Then there's the CDT adapter from CDT.cloud. This is the one which we integrated into the CDT.cloud Blueprint. And last but not least, there's code LLDB for everyone preferring LLDB over GDB. For our embedded friends, there are two extensions which I know which are heavily used, and I only heard good things, which are native debug, which, for example, supports remote GDB debugging, and there's Cortex debug for the Cortex microcontrollers, and for example, also brings in its own register views. So let's take a look at debugging in the blueprint. Yeah, let's close our ClangD workspace again and go over to that. Okay, let's set a breakpoint, for example, here. And yeah, let's just run our application. And we can see, we pause on the breakpoint like you would expect. You have your local variables, which are our two rectangles which we have. And here, for example, we have our first rectangle with a width of 3 and a height of 4. And we can even modify the memory. So I will just set a new value. Let's take 5. You can see it's updated. And yeah, let's go step by step. And when we call the area of the first rectangle where we just changed the 3 to a 5, then we get a new output. So let's go over that and let's take a look. Aha, it's 20, like what we would expect. Yeah. I guess that's all that's to it for this presentation. Now I want to highlight a very nice goodie, which is the debug memory inspector. This was recently, so at the end of last year, contributed to Theia. At the moment, it's Theia only, so it can't be used in VS Code. And yeah, it was tested with the CDT GDB adapter, but it should, in theory, work with other adapters too. And actually, it should not only work for C++, but it's generic enough that you can add other things to it too. Yeah, it's part of the Theia CPP debug package, which is not part of the core Theia repository, but it's a separate CPP extensions one. But it could very well be that this will be moved because it doesn't necessarily have to be CPP specific. So I also wanted to show you this. So yeah, let's just start debugging again. And this time, let's go to our variables and say, okay, I want to see it in the memory inspector. And yeah, there we can already see it. So there's our first rectangle, there's a second rectangle. Yeah. Now I will do something which might also already let you suspect what I want to showcase. I will rename this memory view to before. I will open another one. And I will rename this to after. And let's move a step. And if you look closely, you already see there's highlighted the part of the memory which was changed. In this case, we set the values 5 and 6. And which is also nice is that this view not only can be used like this, but it also provides a diff view. So in this case, we will now compare before with after, and this will open in a separate diff. And there you can nicely see the difference, which is very useful if it's not like an immediate step like here, but if you want to compare two completely separate points of execution in your program. Last but not least, I wanted to highlight tracing. So there's Eclipse Trace Compass. You might be familiar with that already. It's a very popular Eclipse RCP-based tool, but they are now going into working into integration into web tools and especially into Theia. And they do this via a protocol. It's just an architecture which makes sense for the web. So let me very, very quickly show this to you too. So let's get back to our application. Let's just close everything so we have a little bit more space. And here, let's open our tracing. Yeah, for example, we can look at CPU usage tracing or some resources which were involved. So actually, very nice thing. If you want to know more about the Trace Compass and the road towards Theia, I can highly recommend the Trace Compass Cloud Eclipse Trace Compass Migration towards Theia talk from the Theia. No, it was from the EclipseCon 2021. And I think even here in the Cloud IDE days, we have a talk regarding Trace Compass. It's an IDE to develop, trace, and debug cloud and HPC applications. So I'm looking forward to that. With that, we already come to the conclusion. So the web is a very fast-moving platform, has a lot of potential, and it seems C is a very good fit. Yeah, many embedded vendors are already adopting Theia. So when you think about the Arduino IDEs 2.0 or the Cloud by ARM, they're already using it, and many more are coming up. And yeah, as you can see, even just by building or integrating some basic open source components, you already get very far. I can heavily recommend, again, please look at cdt-cloud.io to stay up to date and to also get the latest news about our CDT.cloud Blueprint. With that, Let's open for questions. And actually, this was super fast. So if there are many questions, we actually have some extra time. However, if not, then that's also fine. Let's look at the first question. What language support did non-cloud CDT use, and has anyone tried to turn that into a language server versus ClangD, or was there overlap? Good question. Yeah, as a non-cloud CDT is basically an old, so it's Eclipse CDT, Eclipse RCP based. So it's like what you would call today old school IDE. So the concept of a language server was not around when this was initially started. So the Eclipse CDT language support is definitely homegrown. I think it's even written in Java. Yeah. So yeah, I don't think that this was directly turned into a language server. However, there's definitely also the opposite approach there in Eclipse RCP to bring in language server support into Eclipse. So you could then connect instead, for example, ClangD to Eclipse RCP. However, I think this is at least not as well supported as the traditional way. Okay, going to the next question. Which companies are involved with CDT.cloud so far? Yeah, CDT.cloud is a very young project. So at the moment, there are a few major companies. There's definitely Ericsson, who are working on the Trace Compass Cloud now. Also, they worked on that before CDT.cloud exists. However, they moved over to CDT.cloud. There's Renesas, and there's ST Microelectronics, and of course Eclipse Source, where I'm part of. Yeah, CDT.cloud is definitely open. Even on the website, we have an extra button where you can suggest components which should exist. There are plans for further migrations, and if more companies are interested, they're definitely welcomed. So let me see for the next one. Can the ClangD language server be used regardless of what C++ compiler that will be used for compiling the code? In particular, is it fully compatible with Microsoft C++ compiler? So in the end, what ClangD invokes in behind it is Clang. So in the example I showed, we already actually used GCC as a compiler, because this is one which is very often used in the embedded world, and this works mostly fine because Clang also tries to be compatible with GCC. Yeah, but there are hiccups, like the error I showed, which was because Clang did not understand the parameter to GCC. Regarding the Microsoft C++ compiler, I'm actually not that familiar with running ClangD against that. I did not do that yet. From my understanding, it's that Clang is definitely interested in being compatible with the Microsoft C++ compiler. I think even ABI compatible. There are some compatibility settings you can do there. So I did not try it. I would expect that at least some things, basic things, should definitely work. But I actually don't know. So if it crashes horribly and burns, just the very basic things could happen. But yeah, this would be my expectation. So I see. Okay, that's already it with the questions. Perfect. I was very happy to give this talk. Thanks for your interest, and I guess see you at some point in the future. Bye.